Alright, we'll find a unit rate from the given information, and we'll find the specific rates that they ask us to find as well. Just using the same methods that we've already used, usually some kind of fraction. But for the most part, we will be using the unit rates because, like we saw last time, they're a little bit easier to use to find the different rates, okay? So then we'll answer those, and models may be useful, but we're just going to use proportions to solve these. So this first one, we're comparing two things. We got some cookies, and we got some cups of flour. And right up in here, it says you got 24 cookies with 4 cups of flour. Now we got to be careful and look at what it's asking for. It says that it wants to know what the unit rate of cups of flour per 1 cookie is. So when we compare this to an equivalent ratio, we want to compare this to 1 cookie up in here. And we'll figure out how many cups there is. So we need to change 24 cookies into 1 cup. And since it's a ratio, we'll divide this by 24 to get the 1 cup. But then we divide the 4 cups by 24 as well, which gives us a 1/6 of cups. So 1 cookie would be 1/6 of a cup. Yeah, I would say keep the fraction on this because they don't really sell like cups of flour in decimal values. But if you wrote the decimal, that'd be fine. 0.17 rounded. So how many cups of flour would be used for 20 cookie? Well, so I'm going to go back to this unit rate. I got 1 cookie for 1/6 of a cup of flour. And I need this to equals some ratio with 20 cookies. And I want to figure out how many cups. Alright, so to figure this one out, I take the 1 cup and multiply that by 20 to get my 20 cups. Cookies, rather. But then I'll take my 1/6 of a cup and multiply that by 20 as well, which would give me 26, which I could then simplify to 10/3. Now in cups, that means you take 1/3 of a cup, fill it 10 times with flour, and pour it in. Bam. And you got 20 cookies. Next up, what is the unit rate of cookies per cup of flour? So up in here, I'm going to go back to that same unit rate, 1 cookie for 1/6 of a cup of flour. And what I want to know, however, is how many cookies I can get for 1 cup right here. And so what I would do, so I would take my 1/6, I need it to be 1 cup. So you could either say I need 6 of those 6 cups, or if you divide something by itself, you get the 1 cup. So I got 1 divided by 1/6. But as we hopefully remember, when we do 1 divided by 1/6, we don't usually divide fractions like that, so we reciprocate them and multiply. So 1 times 6 over 1 would be 6 cookies for 1 cup. How many cookies could be made with 5 cups of flour? So we got these 2 unit rates, and we want to know how many cookies for 5 cups. So I'm going to use the 6 cookies from the 1 cup. But now I want to know how many cookies with 5 cups. So how would I figure these? Well, how do we get 5 cups from the 1 cup? We're just multiplying that by 5 to get 5 cups. So we'll multiply the 6 cookies by 5, which leaves us with 30 cookies. And yes, I do like my cookies with raisins and chocolate chips.
No raisins.
And oats. Oats and peanut butter and raisins.
Yeah. No raisins.
And craisins. Part E, how many cookies could be made with 0 cups of flour?
0.
Well, as it turns out, if you have no flour, you get no cookies.
Actually, you could just have flourless cookies. That wouldn't be a cookie.
Yeah, but that doesn't really work for this particular example. Alright, the table shows the total number of inches of snowfall for each 1/2 hour. what is the unit rate of hours per 1 inch? And we can see right here that it shows 1 inch right here. And how much snow? No. Yeah, 1 inch. That happened in 1/2 of an hour. 1/2 hour per 1 inch. Which was nice because that happened in the table. I guess it kind of told us up in count as well. Number of inches of snowfall for each half hour. I guess it didn't say that, but whatever. 1/2 inch hours per inch. So, at this rate, if there's 7.5 inches of snow, how long has it been snowing? Alright, so again, it's good to set these up using ratios and proportions with labels so we know what the heck we're doing up in here. And we already know that if you do it for a half hour for snow,
Wait, I have a question, Mr. Sal.
you'll get 1 inch right here. Alright, so on at these, how do we get from 1 inch to 7.5 inches? Well, we'd multiply that by 7.5 to get 7.5 inches. So, I'm going to multiply 1/2 hour by 7.5 as well. And I should get about 3.75 hours.
Wait.
Now that would be the decimal if you wanted it. But on the other hand, we wouldn't put the mixed number. We would put the improper fraction, which would be 15/4 hours. Thank you.
I cannot read your handwriting.
Is what is the unit rate of inches per 1 hour?
Wait, I have a quick question about
So write it down. What is the unit rate of inches per 1 hour? And again, this showed it to this in the table right here. We can see that it's 2 inches every 1 hour. Well, the next part is we want to know how many inches would fall for 2 1/3 hours. And that's kind of where the difference comes in. Is that now we're looking at 2 1/3 hours. But of course, we don't usually compare this with mixed numbers, so let's change this into an improper fraction, which would be 7/3. And we're looking for inches right here. So how do we get 1 hour to be 7/3 hours? We multiply it by 7/3. So we'll multiply the 2 by 7/3 as well. And I got 14/3 inches. That, of course, was for part D. This table shows the cost of a plumber for the amount of hours worked. Now, we got to look at this right here. And some of you guys notice that at 0 hours, they're going to make some $45, which is pretty cool. Just that, here's the thing with plumbers, and you guys could call any plumber, they would tell you these, is they'll probably charge you some kind of upfront fee because if they're coming out to your house, even just to check, it's making them so that they can't do work somewhere else. So they'll have to charge you $45. Or they may charge you for materials, which is required for a job, or both. Okay? So yeah, sometimes plumbers will charge you, electricians are the same, and HVAC people, they will charge you monies without actually doing any works. Okay? Oh, I just explained why, so it's not dumb. All right.
Are you a plumber?
I do plumbings.
Why?
But what do you guys notice that's different about this table? Well, before we had ratios that were equivalent, like this one, right? If we look at 1/70, does that equal 2/95?
No.
No. Those are different, completely different ratios. And in addition to these, for the most part, if you had 0 something, you had 0 of the other thing. But this one's showing 0 hours and $45. So that is why this table is extremely different. Is there a unit rate or a proportional constant? Well, since this one, because it's at proportional right here, right? Is this proportional? Well, we've already seen that between the 1/70th and the 2/95th, that they are not proportional. So no, there is no proportional constant that we could find. And so is the relationship between hours worked and cost proportional? No, it is not. Now the problem with this is that we get kind of new to this whole concept. And we may look at these and think, well, how much do you guys think is the plumber's making every 1 hour? Yeah, so we look at that and we think, man, this guy's making $70 per hour? What kind of garbage is that? The answer is no. That is correct. Thank you. That includes the $45. So in actuality, how much is this guy making every hour? Well, we got to figure out the change from 45 to 70.
25.
That was $25 in 1 hour, which is still pretty good.
Is it
That's
45
true.
plus 45 is 70?
Now look at this. 70 plus the 25 as well would give us the $95.
$25.
And so the rate is consistent that he's earning money, $25 every 1 hour. And this continues throughout the rest of the table, but it's important to know that this guy is not making, or this lady, the plumber, is not making $70 per hour and then $95 for 2 hours. They're making $25 every 1 hour. Arturo can run 1 3/4 miles in 1 hour. What is his speed in miles per 1 hour? So I'm going to set this up using a fraction once again. I got 1 3/4 miles every 1/4 hour. But yes, that's very good. We definitely do not want mixed numbers. So I'm going to make this 7/4 every 1/4 of an hour. But the problem is we want to know how many miles this Arturo can run every 1 hour.
I like that.
Okay, so we can put the 1 hour right there and show that it's a unit rate. So the question is, how do we take 1/4 of an hour and make it 1 hour? Some of you guys would say times by 4. We can divide it by 1/4 as well. Because 1/4 divided by 1/4 is 1. So we can take the 7/4 and divide that by 1/4. So let's show the work over the count. I got 7/4 divided by 1/4. But we never usually divide fractions. We only multiply them. So this is really 7/4 times 4 over 1, which is 28/4, which is 7. So it appears that Arturo can run at a blazing 7 miles every 1 hour. Part B, so we can use that unit rate then, 7 miles every 1 hour, and we can figure out how many miles good old Arturo can run in 3 hours. So the question on it is how could we do, yeah?
You times 7 by 3 because you times 1 by 3 to get 3 hours.
That is
and then you
excellent.
times 7 by 3 because you have to both sides.
Correct. And how many miles is that?
21.
So every 3 hours, Arturo gonna run 21 miles. Number 4, the side lengths of triangles A and B are proportional. So triangle A has a side length of 4 inches. Then corresponding side length on triangle B has a length of 5 inches, which is shown in the table. And these are in inches. So when we look at the lengths, we've got triangle A compared to triangle B. And then in the table, we can see that for triangle A we get 4 inches and triangle B would be 5 inches. But then the next value is 3 inches for A. So what we can do actually is we can figure out how many inches for 1 inch to find for 3 inches on triangle A. So to do with these, we would divide both of them, these two, by 4. So this would be 5/4 inches. And then we would multiply this by 3. And then we would see we'd get 15/4 inches. So right account, we got 15/4.
What the?
That was the purpose of this middle one, is to change this into a unit rate, so then I can use the unit rate to figure out how many inches for B when triangle A has a length of 3 inches. Now here's the problem, is this next one has a length for triangle B. So let's look at this 4/5. And now we're going to change this to 1 inch for B though. So to do with these, we'll divide that by 5 to get the 1, but we got to divide the 4 by 5 as well. Now if you got 4/5, that's fine, but if you got the decimal, you'd get 0.8 inches for A for 1 inch on triangle B. And now we'll just expand this to show for 6 1/4 inches on triangle B, but you guys said you wanted the decimal on that, right? So 6.25. So how do we get that? Well, we'll take the 0.8 and multiply it by 6.25, because the 1 would have to multiply that by 6.25 as well. So 0.8 times 6.25, thank you, that would be 5 inch. So I can fill that in right now at 5 inch.
Wait.
Alright, then what is the unit rate for the side lengths of triangle triangle B? 2A. We already did that unit rate. So that means that the A would be the 1, which was shown right up in here. So that would be 5/4 inches to 1 inch. But you guys like the decimal, so, well, not 0. But 1.25 inches to 1 inch. Alright, number 7, there were 7 inches of rain in 24 hours. If this rain continues, how much rain will have fallen in 30 hours? Well, we've got to look at these. 7 inches in 24 hours. And we want to figure this out for 30 hours. So yeah, I like that suggestion. How many inches? It would be good to compare this using a unit rate. Now the unit rate, do we want it to be 1 hour or 1 inch? Yeah, probably 1 hour on this, okay? Because then we can multiply that by 30 to get the 30 hours. So the question is, how many inches would that be in 1 hour? Well, we'll divide this by 7 round count. And we'll, not 7, 24, dang it. Yeah, right.
Someone already wrote my notes.
That's so much up.
724.
Is that you?
Alright, 24, let's go on that one. 24, so I'll do 7 divided by 24. And I got, alright, 7/24 will work. Well, for these, we're going to multiply the 1 hour by 30 to get our 30 hours. And so we'll multiply the 7/24 by 30 as well. And if we were to simplify these, it appears we would get 25 sixths. Fourths, thank you. So 35, yeah, 35, what the heck. 35/4, which is about 8.75. Look at 9 and 10. 9 right account. It shows we got a CD Express which offers 4 CDs for $60. But then Music Place charges $75 for 6 CDs. And which store offers the better deal? And we'll justify that using unit rates. So let's look at CD Express first, which shows we got 4 CDs for $60. Now it doesn't matter which unit rate we use, we just got to be careful with how we interpret the rate. So do we want to figure out how many dollars for 1 CD or how many CDs for $1?
How many CDs for $1?
No,
Alright.
how many dollars for 1 CD?
Yeah. No.
Yeah. Alright, whatever. 1 CD. Alright. Now this should come out a little bit better because both those are divisible by 4. It will avoid fractions on that. For example, to make 4 CDs 1 CD, we'll divide that by 4 to get 1. And we'll divide 60 by 4 and it would show $15 for 1 CD. Now that was CD Express, so we got to look at Music Place as well. And we'll compare these unit rates. Now if we want them to be the better deal, are we looking for a lower price for 1 CD or a higher price for 1 CD? A lower price, okay? So if Music Place has a lower price, lower dollars for 1 CD, then they are the better deal. And right here, it shows for 6 CDs, they will sell them for $75. But what we want to compare this is against 1 CD. So we'll divide these by 6 to get 1 CD and the $75 by 6 as well, which is how many bucks? 12.50. So the question is, which of the 2 places is the better deal? Yeah, the Music Place is less dollars for every 1 CD. Let's look at number 10 then. Tia is painting her house. She painted 34.5 square foot in 3/4 hours. At this rate, how many square feet can she paint in 1 hour? So each hour. So let's go ahead and compare these. We got 34 and a 1.5 square foot for every 3/4 of an hour. And we want to compare this. How many square foot can Tia do in 1 hour? But the problem is we got a mixed number up in count. So we need to change that into an improper fraction. So 67 halves. Very good. Alright, so 69 halves is square foots per 3/4 of an hour, but the same idea on it. These, we'll divide it by 3/4 to get the 1 hour. We'll divide both of them. But the problem is we don't divide fractions. We only multiply them, so we'll multiply this by 4/3 instead. And simplifying it these, the 2 and the 4 simplify, and then also the 3 and the 69er would be 23. So yeah, it looks like it would be 46 square foots every 1 hour. So part A, it says on number 8. So the first, we got the times for these 3 runners. Runner A can run 5 kilometers in 34 minutes. Runner B can run 10 kilometers in 62 minutes. And runner C can run 21 kilometers in 155 minutes. Alright, so let's find the rate of kilometers per 1 minute for each of these runners. So we're looking for 1 minute specifically. Let's look at runner A first, who can run 5 kilometers in 34 minutes. So we'll compare this to 1 minute and figure out how many kilometers there are. So we'll divide that by 34 right account to get the 1 minute, and we'll divide 5 by 34 to get 5/34. Now we will be comparing these, who has the faster average rate. So we probably should write this as a decimal. So runner A is at about 0.147 kilometers every 1 minute. Alright, so that takes us to runner B, who can run 10 kilometers every 62 minutes. But once again, we want this compared with 1 minute. So we'll divide both of these by 62 to get the 1 minute, and divide this by 62 as well. And that's in kilometers. So runner B has 0.161 kilometers every minute. So just based on these two values, who is running at the faster rate? B is, because they're covering more kilometers in 1 minute. Okay, now it's very small in terms of kilometers and decimals, but it's still more. So now we need to compare runner C. So runner C, but we want to compare this to 1 minute and how many kilometers. So we'll divide both of these by 155. We'll just change this one directly into a decimal. So 21 divided by 155. And we got 0.1. I can round that to 4. So here's the problem is A, and that's good that we rounded that one to the hundredths, thousandths rather. But we can see that the fastest person is, which runner will finish the rate at the fastest average rate? Yeah, it's going to be runner B, because they have more kilometers every 1 minute. In 2.5 hours, Daniel's brother can ride 40 miles on his bike. How many miles can Daniel's brother ride on his bike for? 4 hours. So let's look at his rate. Up here, we got 40 miles in the 2.5 hours. But what we want is 4 hours. So again, I'm going to find the unit rate for 1 hour, so I can just multiply that by 4 to get my 4 hours. So we got to figure out how many miles he can go in 1 hour.
Did you divide?
So 2.5 to get 1, what divided by itself? 2.5.
1.
And then 40 divided by 2.5.
16.
16 mile every 1 hour. But that doesn't answer the question, it just tells us the unit rate. What we really wanted to know down on yonder was how far the brother can go in miles in 4 hours. Well, up in here, we would multiply this 1 hour by 4 to get 4 hours. And the 16 by 4 as well. And we find that Daniel's brother can ride 64 miles in 4 hours. 64 miles in 4 hours. Now the next one shows how long will it take Daniel's brother to ride 152 miles.
9.5 hours.
So to do with these, we will look back at the 40 miles in 2.5 hours rather. And we're looking for the other unit rate with 1 mile now, so that I can scale that by 152. But we got to figure out the hours up in here. So this one appears to be 16/5, right? Because we divided this by 40. So we'll divide this by 40. I think that's a 16 over 50. There you go. I did that very different. So we got 1/16 or 0. What the heck was that? 0.625. Now that was for 1 mile, but what we really want is 152 miles. And we'll figure out how many hours that is. So to do that, we'll multiply the 1 by the 152, and the 1/16 or the 0.625 times 152 as well. So when we do that times 152, bam, 9.5 hours.
That's a lot of hours.
Which also could have been written as 19 halves hours.
19.5.
There we go.
Oh, masters now.
So for one of the other classes, we looked this up, and we found that a 20.5 ounce box, and this was a good old-fashioned Lucky Charms, was something like $3.69. Okay. And then we had another box that was 25.6 ounces, and this one was for, I don't know, I don't remember how much it was. Let me think. Alright, so what you guys need to do is take a moment and figure out which of the two boxes of Lucky Charms costed more per ounce. So you need to figure out both unit rates and figure out which one was the most expensive or the better deal. If we can figure out how many ounces we can get for $1 or how many dollars it is for 1 ounce, then we can compare the two. So it seems like it may be easier to compare dollars per ounce. So I got $3.69 for 20.5 ounces. That's ounces. So how many dollars would this be for 1 ounce is really what I should look at. And after I round, I should get 18 cents per 1 ounce. Okay. Now on this next one, we'll do the same thing, except for we got $5.38 for 25.6 ounces. That's a 6. And we want to know how much it will cost for 1 ounce. So to do with these, we'd divide the two and would find that this one is about 21 cents per ounce. Now the thing that's unusual about this is usually buy bigger boxes because it's supposed to be cheaper per ounce. But unfortunately that is not always the case. So you got to be careful on that stuff and make sure that you buy boxes that are actually a better deal. But yes, the 20.5 ounce box is the better deal.
Wait, but